In this question, it is given that tank is filled with water of density 1 gram per centimeter cube and oil of density 0.9 gram per centimeter cube. The height of water layer is 100 centimeter and that of oil layer is 400 centimeter. If G is equal to 980 centimeter per second square, then the velocity of efflux from the opening of bottom of tank is. So first of all, just try to understand the situation over here. So we are considering a tank over here, and some part of this is filled with the liquid and the remaining portion is filled with the water, or some part is with oil and some part with the water. So it is given that tank is filled with water of density 1, and over here it is given that the density of water is 1 and oil is 0.9. So water is going to be at the bottom, or we can just imagine that if the density of liquid is more, it will be on the bottom side, or if the density of liquid is less, it is going to float on the higher density of higher liquid of higher density. So just consider that oil is over here on the upper part and liquid is on the, or water is on the lower part. And density of this liquid is given as nothing but 0.9 and density of water is given as nothing but 1. The height of water layer is 100 centimeter. So height of water layer is given as nothing but 100 centimeter, and that of oil layer is 400 centimeter, and the height of oil layer is given as nothing but 400 centimeter. And acceleration due to gravity is also given, and you can here observe that in this question every value is given in CGS system, and even the answer is also given in CGS system. So we are going to write all the calculations in CGS system. And a small hole is make at the bottom. So let's say we are just considering a small hole over here, and as it is water over here, water is going to come out with some velocity. Let's say that is equal to v, and our aim is to find out what about the value of velocity over here. So we are going to just apply Bernoulli's theorem between these 2 points. Let's have one point which is inside, take it as 0.1, and the point which is outside, take it as 0.2. So between these 2 points, if I am applying Bernoulli's theorem, so take it as pressure at 0.1 plus half into rho into V1 square plus rho into G into H, or H1, is equal to take it as pressure at 0.2 plus half into rho into V2 square plus rho into G into H2. Now for the calculation of gravitational potential energy, I'm just taking this bottom of container as nothing but our reference line. So pressure at 0.1 is nothing but, over here the pressure is due to pressure exerted by atmospheric pressure, let's say P atmosphere. So you can write this as P atmosphere plus pressure due to this oil plus pressure due to water. The equation for pressure due to liquid column is H into rho into G. H is the height of liquid column, rho is density of liquid, and G is nothing but acceleration due to gravity. So you can write H of oil column is 400, density of oil is 0.9, acceleration due to gravity is given as nothing but 980 plus, now we can write the pressure due to water column, that is equal to 400 plus density of water is 1 and acceleration due to gravity is 980. And next we need to write the equation for kinetic energy, as the velocity of liquid inside the container is almost equal to 0. We'll take it as 0 plus the gravitational potential energy is also equal to 0 because we are taking this bottom of container as our reference line. This is equal to pressure outside, that is equal to nothing but atmospheric pressure, plus we can write half into density of water, which is 1 because water is coming out, so density of water into V2 square. Our aim is to find out what about the value of velocity, and gravitational potential energy is equal to 0 with respect to our reference line. So you can cancel this P atmosphere and P atmosphere. So this we can write is equal to nothing but 3.6 into 10 raised to or into 100 into 980 plus this we can take it as something but 100 into 980 is equal to nothing but the value of v square divided by 2. So we can write this is equal to nothing but 360 plus 100, that is 460 into 9.980 is equal to v square divided by 2. So we can write this is nothing but 2 into 460 into 80 under root is going to be the value of v over here, or you can rearrange this one as equal to v is equal to under root of 920 into 4980. Under root of this will be the value of velocity.